Okay, just a subtle point about this. I didn't realize it at the time, but I've actually done this problem before in this problem set. And the reason for that, I do a lot of problems, and sometimes I can't remember. However, every problem I do looks like a familiar problem to me. All right, and that's something about doing a lot of problems. Things become very, very familiar. So when I saw this problem the other day, I did see the video posted to it. There is a video. They want click on the link. You can watch that guy do it. But certainly, when I look at a problem like this, I realize they're on the internet and they're. I'm not going to say they're difficult problems, but they're problems that if you thought about it, you'd probably come up with an answer to it pretty quickly. By the way, the other one I claim over here is that if it were a difficult answer, it's going to take me some time to get to it. All right. Now, some of the mistakes you might make is raising both sides to the least common multiple between 3 and 2, which would be 6. And then kind of denesting roots and things like that. A lot of work. So let me explain what I did initially when I saw that. All right. So I'm going to go to the whiteboard, and I'm going to write the problem down. And the problem I'm looking at, I got to remind myself now. Give me 1 second. Got to get my document over here. They want me to solve this equation over here, which is 1 plus the root of 1 plus x equals the cube root of x. Now, before I do anything, I would like to look at it's a real, again, x is a real number. So I got to be really concerned about this. And what I know about this is the square root's a principal root, so it's got to be a positive number. So looking at it, I'm going to say the x would have to be greater than or equal to 0. Now, granted, you may look at this and say, well, x has to be greater than or equal to -1, but this is a stronger condition that needs to be met, all right? And the reason for that, it's got to be the principal root, all right? So I'm going to say I'm at that level at the game right now. I know my answer, if it's there, is between 0 forward. It's a positive number. I know it's not 0, by the way. Looking at it, there's no way it could be 0, right? So let me erase this over here. Oops. And talk about what I initially did. Now, granted, the last time I did the problem, I can't remember what I did, but I know it's in my notes, by the way. I scrolled back over my notes, and I did see the problem, all right? Because I had suspicion after I did. I said, I think I've seen this before. It's like sometimes I watch a movie, a half hour in, I said, hey, I've seen the movie before. And then I kind of recollect, yeah, I saw it. I know the beginning, middle, and end now, all right? So what I did was over here, I started saying, I'm going to look at perfect cubes. And certainly I look at one's a perfect cube. You may wonder why that is. I'm assuming it's an easy number, right? 1, that's not going to work though, is it? What would I get? I get 1 plus the root of 2, and that definitely does not equal 1. There's no way, all right? So what's the next perfect cube I go to? Let's see, 1 cubed, 2 cubed, right? That would be 8. Now granted, some people call this a hunt and peck, but I got a suspicion it's going to be an easy number. And what do you get over here? Let's write this down. I'm going to check it now. It's going to be 1 plus, 1 plus 8, excuse me, is 9. I'll write that over here. And then I get the cube root of 8. I know the cube root of 8, that's why I've chosen it, by the way, is 2. And what's 1 plus 9? That's going to be, 1 plus the square root of 9. That's going to be 1 plus 3, which is 4. And this works. So I got my answer, all right? Then I start to wonder, what does this thing look like? And I know what it looks like. I'll tell you what it looks like. It looks like, the cube root function looks like this over here. That's easy for me to draw, by the way. Now, granted, I'm not saying it's a detailed picture of it, but this over here is y equals the cube root of x. Now, if I were to graph this out, a little more complicated, I'd probably start at -1. And if you started at -1, what you get? You would get 1. Put this over here. And then, like if I put a 0 down, I get the root of 2. So I'm going to say it looks sort of like this over here. And this is just a rough picture of what it looks like. But what I do know, they're going to intersect somewhere, all right? Where they intersect at a point 8, comma, and that would give you 2. That's where they intersect. All right, let me go through the other technique, by the way. And that's like, I did that. I thought through it. Not very elegant, but I did think through it. What did I depend on? I depend on this thing being a nice integer number. And it is a nice integer number. Now, if it weren't a nice integer number, let's say we're between 1 and 3, between 2 and 3, I would at least have a bound where to start and look for this thing, all right? But let me go through this over here again, the algebraic technique, and let me write that problem down again, and I'll talk about an algebraic technique to this. The problem with algebra is you kind of stop thinking about the problem. At least I would. And what I'm going to do is make a substitution. I'm going to say u is equal to the root of 1 plus x. By the way, the x Still has to be greater than or equal to 0. All right, still has to be, because I went back to the original problem. I know that to be true, by the way. So if I saw that, I know u is a positive number at this point. All right, and then I'd let v equal, let's see, the cube root of x. And just to simplify a little bit, this would be u squared. And yet, you're right, I'm introducing another variable here. Actually, two, u and v. This would be 1 plus x. And this would be v cubed is equal to x. So just from this substitution over here, I realize there is a relationship between u and v. What's that relationship going to be? Well, let's see. U squared would equal 1 plus, well, x is just v cubed. I'm going to claim this is an important thing over here. The next thing I would do is I'd substitute in here. What do I substitute in? Let's write this down. 1 plus, well, the square root of 1 plus x is just u. And the cube root of x is just going to be v. All right? What do I do now? Square both sides. I get 1 plus u equals, that's not so bad, right? And then I look at this thing over here, and I see the u. Let me put this over here. So I'm going to say, let's see, it's a little complicated now, isn't it? I'm looking at this and wondering, this is also an equation in u and v, and I wonder if I can eliminate something. And I'm looking, maybe I can eliminate the u. Now, let me see if I can do that. So u, this would be equal to v squared minus 1. I'm going to square both sides. Again, I want to point out, this is reasonable because squaring both sides is not going to really affect the problem at all, because u is a positive number, by the way. So what do you get over here? v4 minus 2v squared plus 1. Okay, what am I going to do over here? I'm sorry, it's u squared. I'm going to plug this into here, and I'll eliminate something. So let's write this down. So I get v4 minus 2v squared plus 1. You notice I'm no longer thinking about the point of intersection. I'm thinking about solving an equation now. And what do you give here? 1 plus v cubed. All right? Looks like a tough equation, fourth degree polynomial, but I'm going to give it a shot. What do you get? v4 minus v cubed minus 2v squared, and the 1's disappear. I'm going to factor out v squared. And what do you get over here? Let's see, v squared minus v minus 2. What do you get over here? V, and then I get v, let's see, minus 2, v plus 1 equals 0. This is v squared. There's 4 roots. I'll write them down for you. 0, 0, 2, and minus 1. All right, this is what v is. Let me go back over here. And remember, v's got to be positive number 2, by the way. So you want to say that it can't be 0. So I'm going to say it can't be that, can't be that, can't be that. Only got one result, which is 2. Let's go back over here, and let's see if we can figure this out, by the way. So again, v is 2. I'll write this down for you. 2 is equal to the cube root of x. What's x? X is 8. Is that what we found by inspection? Of course it is. It really is. What might be more elegant? I really think by inspection is more elegant. I think looking at something, coming up with a reasonable conclusion about what it is, and going with it and checking it, all right? Also, a rough graph might be helpful. I want to point out in the notes, by the way, I'll go back to that. I do speak through this, and I basically do the same technique at the whiteboard, by the way. But I say my graphs are really done in the whiteboard. They're kind of like very primitive graphs, but I did graph out a better graph over here with the understanding. I hope you realize that we did sort of something like that. That was the cube root problem, and this was that nested square root problem. All right, where they intersect, right over here. If you looked at that, I want to point out, looking at that, kind of tracing down. And again, it's kind of like hard even to look at this over here, but I get what I expected. The point of intersection would be 8, 2. And a picture is nice to have. What allows me to do this? The use of technology. And I do recommend that you start using and learning how to use technology. All right, what technology you're going to use, that's up to you, by the way. I'm using an application here called Grapher. I do like Grapher. However, it's a very dated application. I think it's more than 20 years old now, but it's still being installed in the utility folder of the Mac OS X. All right, thank you.